EPQ stands for economic production quantity. One key to success with the EPQ formula is knowing when it's time to use it. We are looking for some certain thing in the problem that is our sign or signal that it's time to use it. Let me take a look here and show you. Suppose we must produce 500 of some SKU annually. I'm going to stop right there, because that statement that we've got to provide 500 of something annually is a big hint that I have found capital D, annual demand. Right, we need this parameter capital D for the EPQ formula. It is known as the annual demand. You might say, oh, well, I didn't see them mention anything about demand in that particular problem. No, but it said that we must produce. Okay, that's another hint. We apparently are the people who make it. We must produce some overall amount annually. That's telling us that's capital D. Okay, now, continuing on. And we must produce 500 annually, and we can produce 50 units a day. Perfect. I've got to jot that down somewhere. That is the production rate. Lowercase p for daily production rate, 50. That was my signal that this is time to use the EPQ formula. Of course, another signal is that the whole thing is printed here below the problem, right? But if that wasn't there, the fact that there's a statement about how fast this item is made is telling me that it's time to use the EPQ formula, not its very similar looking cousin, the EOQ formula. Oh, all right, anyway, but we've got to go ahead and use the formula. Okay, during our 250 working days each year. Now, that's a very interesting piece of information. It doesn't go into the formula exactly, but I'm sure maybe that we're going to use it for something. It costs us $10 to set up production. Ooh, I'm intrigued by the word set up. Regardless of the size of the batch we produce. Perfect, I have found S. The fixed cost associated with the order. In production settings, our order size is very often referred to as our batch size. Remember, in production settings, we make the stuff, so we often refer to it as a batch. S is any fixed cost. You got to pay it no matter how big a batch or how small a batch that they just reported it. All right, what else are we told? And it costs us $1.25 to hold 1 unit in inventory for an entire year. Now that sounds like a very strange thing to do, but we are very grateful that they volunteered that information because we don't have to work for it. That is capital H, the inventory holding cost. Remember, in this formula, capital H is literally the cost of holding one of these things in inventory for an entire year, and they just reported it. Okay, so I think we have everything we need to. It says, what is the best batch size? Right, this is the EPQ formula right here. It gets you the best batch size. What do we mean by best batch size? These costs have been associated, setting up, holding. It's the lowest cost batch size. All we have to do is fill it in. Oh, all right, so I'll fill it in. And I say, okay, let's see. So it's the square root of 2 times the D was 500, right? And then the S was 10. Okay, all under the square root. And then, oh, careful, all under the square root. The H is 125. Okay, and then over here, this is multiplied is what I mean. Square root, the P is 50 over 50 minus... Whoops, maybe we weren't quite ready to fill out the formula because I'm looking at my notes on the scenario and I don't see a lowercase d. Now, very important, what is lowercase d? Lowercase d is daily demand. All right, well, when we were working through the problem, they didn't volunteer that, customers demand or use or purchase however many a day. But I think I see the information that we need to figure it out for ourselves because we already know annual demand, right? That we were told. We've got to produce 500, okay? There's a need for 500. And I knew we were going to use this for something. During our 250 working days a year, remember the assumption with these models is that demand is constant. use is constant, meaning the same thing happens every day. So if we've got to provide 500 a year and there's 250 working days in the year, we're open for 250 days, that means that 500 divided by 250, the daily demand or the daily need for this must be 2. Okay, 2 a day. 2 a day. And that's the number that we lack. That's the number that goes here. Think of lowercase d as the cousin of capital D. They are not unrelated, okay, but one is annual demand and then the other one is the daily demand. All right, now what's this work out to? Where's my scratch work? I get, this is kind of messy because of the square root. This is like 89.44, and over here this part works out to like 1.02. So it then comes out like 91.287, of which that's the result of the formula. It's not really a useful suggestion because remember this is the batch size. So that is, I'm pretty happy with rounding it to 91. Remember, we're suggesting a batch size. Like how many of these should you make every time you need some? The answer, we suggest you make 91. Why? That minimizes your combined setup and holding costs. That's why 91's the answer. Every time you need some more, you should make 91. Oh, okay. Now, that's the formula itself, right? That's how you use it. Okay, and I was saying, why is it the best answer? Because it minimizes the costs. Fine. What are those costs? What does it cost to make these 91 at a time? Oh, well, then that's where we bring in the total cost formula for the EPQ environment. We would want to fill out this formula using Q equal 91 because that's our suggestion. Oh, okay, so the total cost, what does that cost? The total annual cost is, now let's see, D is 500, right? Q is 91 because we've decided that. Times, it's just $10 per order or per setup, plus 91's the Q. Let me get the right numbers in the right places. 50 minus 2 is the P minus D, divided by 2 times P is 50, all multiplied by $1.25, the cost of holding 1 unit in inventory for a year. Okay, scratch work. On my calculator, now notice this, let me switch ink colors here. This part of it, 54.95. That part of it, I get like 54.6. Anyway, it isn't either part of it to answer this question that we're interested in. It's, you know, yeah, you got to add them together. I get $109.55. Oh, okay, that's what it costs annually to make these in batches of 91. Okay, that's what it costs annually. That is the lowest possible cost. That's the whole point of the formula. Because you could substitute in any other Q, right? Like Q equal 500, Q equal 2, and you won't get a lower cost than that. Now, one of the reasons why I switched ink colors and I wrote out this scratch work is notice that these two numbers, 54.95 and 54.6, are similar to each other. This is a good check on our math. We were asked to, 1, find the best batch size, and then 2, find out how much that batch size costs. If we did that correctly, those two numbers should at least come out very, very similar. That's what they did in this case. They didn't come out exactly the same because of the rounding I did with the lot size. But you say, well, why is this important? Because that's what the EPQ does. Sketch a little graph. Like, you know, you could use a lot of different batch sizes, right? From nothing, well, that wouldn't make a lot of sense, to bigger and bigger batches. The whole issue here is cost, correct? Think about it. The larger your batch size, the less often you set up, the less you pay in setup costs. However, the larger your batch size, like you pick bigger and bigger numbers, the more of this stuff's going to be sitting around. So your holding costs are going to go up. Oh, right, and the EPQ is finding the one place where they actually, oh, by the way, minimum total cost, where they balance. Theoretically, the EPQ is spotting the one spot where they balance exactly, except we did a little bit of rounding because we wanted a round number, and that's why the two halves aren't exactly the same, but they should be very, very similar, like decimal places. If they're not, you made a mistake somewhere. Okay, but they are, so we didn't. Oh, now, one last little question about the EPQ snuck in on this note frame. Oh yeah, this is helpful to know. Once you decide a batch size, like Q equal 91, right? What's the runtime? Runtime, it's embedded in here, right, from the book. The time required to produce a batch of some item. When you decide, well, let's make these 91 at a time, how long is that going to take somebody to do that? That's known as the runtime. Okay, super easy to calculate. I can give it here as if it's a formula to memorize, Q minus P, but really it's just logic. Think about it. We've decided, using the EPQ formula, they want to make these 91 at a time. The issue is how long does it take somebody to make 91 of them? Well, we already know that we can make them at a rate of 50 a day. So if we divide 50 into the 91, it tells you how many days, and it's not a whole lot of days. It's basically, I get 1.82. If you make these 91 at a time, which you should because that will minimize costs, it's going to take you less than 2 days to make a batch.